Everything good?
Now just start recording the meeting.
All right, guys. So let me start here with the presentation of Tom's lag. So I will share my screen here. Hold on a minute. Here it is. All right. So as I mentioned, we will start talking about what POMS lag is. So remember, POMS is the Production and Operation Management Society, and this is specifically the chapter of Latin America and the Caribbean. So we are, a group of professionals, mostly that are involved in supply chain, logistics, operations, mostly from all Latin America, and it's part of the Production and Operation Management Society that is located in the United States. We have three main objectives. First, encourage the exchange of ideas, experience, and knowledge. That's why you guys are here. That's why we are doing this webinars. We will send you more information about past webinars and future webinars. That are all published in YouTube. Forum for communication and knowledge sharing, and obviously to promote the interest in the field of production and operation management. So despite being a lag chapter, we have members from all over the world. We have people that is located in Asia, in Africa. So there is people that are also interested in this emerging economy. All right, but we are a group of people. So here is the team. We have our regional VP of Americas, that is Diana Ramirez. She is a professor in the Buffalo University. We have our president in Latin America, Professor Gina Galindo. She is the director of industrial engineering at the Universidad del Norte. Myself, I am act as a vice president of the chapter. I'm very honored to join this team. Agata da Silva, that she's with us today. She is the vice president of meetings. We have Carla Tejada. Agata, professor at UPB in Bolivia. We have Carla Tejada. She's a professor at University of Illinois, VP of Communications. We have Professor Sofia Perez. She's our secretary, and she is a assistant professor at Georgia Tech in the industrial engineering program. And we have Oriana Calderon, our treasurer, that are accompanying us. All right, so this is our main team. Obviously, if you have any question of something that you want to clarify, you always can reach us. Any question that you have through the past webinars or the future that we have of the conference that we will explain in a minute, you can come on us. All right, so as I mentioned, we have a lot of opportunities for you guys to go and see what is happening in the region. So as you see, this is some of the webinars, workshop, and master classes that you will find in YouTube. I will send in a minute the link from our YouTube channel. We have people from United States, obviously from Latin America, and we have people from corporations, from industry, and from academia. So you can hear how this is involved in both worlds, even in academia or in industry. So this is some of our speakers. All right, our recent activities. Turns out the last POMS was joined the MIT Scale Latin America Conference. So there were two events in 2024. As you see, that was in Colombia, in Cartagena de Indias. There are some of the pictures. We have around 300 participants. We have half was online, half was in person. People all around Latin America. We have some people from United States, and most of the participants came from university, let's say 80, 90%. And then we have 10, 20% participation from industry. So we are expecting our increasing in participation from companies. So there are some of the pictures that you can have, and obviously if you go to our webpage, you can find more information. So here's the important thing, very important thing. Being in pumps is very easy and it's very affordable. So as you can see, for let's say for the pumps, it costs a little bit more, but for Latin America and the Caribbean chapter pumps is $5. So that will be very easy. You just have to go to this web page. You click there, you create your account, and they will send you, let's say, a registration process. There, the registration process to the society, given that people that are residing, that are located in Latin America and Caribbean, is $25. And then this is $25 to join the society, the whole society, right? United States and all the older region. But to be in the chapter is only $5. As you can see, Latin American and Caribbean chapters, $5. So that will be an amazing, very affordable. Every member of PUMPS can become a member of PUMPS that chapter. All members can participate for free at the virtual events, the PUMPS that chapter board organizers. So we'll have, this is open to public, but we will have some events that are more tailored to only members. All members get discounts of the annual PUMPS like conference. We have some sponsorships in other conference. We have participation in others. So you will find this very useful for you guys. So please scan this QR code and tell us what are your topic of interest, what other events you will like to see, to participate. Maybe you know someone that would like to approach us, someone in your work, in your university. Ideas, we love ideas, how we can improve our chapter. All right, this is the presentation for this. Now I will pass the word to my colleague Agatha, and we'll do the instruction for the talk. All right, Agatha, go ahead, please.
Thank you. Thank you. Welcome, everybody. Thank you for your time. Thank you for your patience. I'm just gonna briefly present to you what Edgar was telling us about our next event next year. So I will replace your share, Edgar, please.
Yeah, let me see, you have it. Okay,
Yeah.
Agatha, you got it?
So,
Okay.
there we go. So we have been sharing this image on our social network. The idea is that we have all the members, you have the choice, you can select where you want our next event to be. We have right now 3 candidates for that. One is in Puebla, Mexico, the second one is in Lima, Peru, and the third one is in Panama City, Panama. So what we were, our aim this month is to have as many members that are willing to go to our conference next year to vote and select where you want to go and how, and help us to make this experience better for you. To vote, you have to be an active member, so you have to go through all the process that Edgar just showed you, and that's very important. And once you are an active member, we are going to send you an email link. If you are already a member, you have been a member for a few months or weeks now, so you should have received the invitation. Please check your email, check in junk mail, check your inbox, and please vote, because it is that what we are trying to make is the best event for you. So we want you to be happy from the destination to the content and the whole experience. So please keep that in mind. And if you are not a member yet, please register. If you have any doubt, you can contact us. And the second thing that I want to do, and I want to be very, very brief here because our speakers are already with us, is to talk a little bit about our networks. We're working we have the previous events that Edgar showed you, we have all recorded, and this one is gonna be also recorded and on our YouTube page. So you can see all the experience that we have shared from people in our network, and hopefully you as members, you can also reach out to us if you want to share some of your experience, some of your research. So the idea here is to generate collaboration, to generate a very nice network among us. So we want to the help of this social media to make this collaboration very active. We don't want us just to be members, but we need to build research and build initiatives together. So here we can see that at Home Slack is our YouTube network, YouTube page. You can reach there and see if you whatever you have there. We have the seminars and the master classes. Like I said, this one is gonna be on our network, on our webpage as well. And we have the POM talks that are directed to people that want to make a master's or PhD in regions. And we are sharing experiences or opportunities from universities in Latin America and the Caribbean. So if you're interested in that, please just take a look on our page and you're gonna see a lot of content. And if you see that there's some content missing, please just reach out to us and we can see if we can find some experts to present about that. We also have our LinkedIn, we have a group on LinkedIn where we usually share all the information, like I said, like the event that we're having now and any other information that we need among the members. And we're just starting a group, a page. So this is gonna be a more open page for all the public, so everybody can see whatever we're doing and hopefully become a member and join our group. So this is what I wanted to share with you. We have already Luis Rabelo here with us. Thank you. Thank you all. So Edgar, I'm just gonna pass the floor to you so you can present.
All right. Thank you, Agatha. Thank you, everyone. So we have full house today. We are very happy for that. We are seeing people from every part. So I have seen very new names. We are very happy for this. All right. And remember, some instructions for the talk. So at the beginning, Dr. Rabelo will walk us through their presentation, and we will have questions at the end. So you want to do the question in Spanish, write the question in Spanish, and we translate for you. You want to write the question but don't talk? Don't worry. Write the question over there in our messages, and we will do the question for you. So, but make sure to do the question, okay? All right, so this is the main instructions. So first, let me present Professor Luis Rabelo. So Professor Luis Rabelo, he was the NASA EPSCoR Agency Project Manager, and is currently the professor and associate chair in the Department of Industrial Engineering and Management Systems at the University of Central Florida in Orlando. He received dual degrees in electrical and mechanical engineering from Panama and master's degree from the Florida Institute of Technology in Electrical Engineering and the University of Missouri-Rolla in Engineering Management. He received his PhD in Engineering Management from University of Missouri-Rolla in 1990, where also did a postdoctoral work in nuclear engineering from 1991 to 1992. In addition, he holds a dual master's degree in systems engineering and management from the Massachusetts Institute of Technology. He has over 300 publications and 3 international patents being utilized in the aerospace industry. He has graduated more than 40 master's students and 55 doctoral students and as advisor and co-advisor. And I was so honored to be one of them. So I'm very happy that I'm very fortunate to be one of them. Dr. Rabelo has consulted from NASA, NSF, that is the National Science Foundation in the United States, NEETS, Lockheed Martin, Boeing, Tyco, well, the many industries in technology. His experience includes Ohio University, Goodrich Aerospace, Honeywell, the National Institute of Standards, NASA, MIT, and so on. So he has received many awards, one in NASA, alumni, best alumni in Technological University of Panama, Fulbright Scholar, two NASA Group Achievement Awards, and many, many awards that he has here that you can check in his profile. All right. So with that, we are very happy to have you, Dr. Rabelo. Thank you once again to share your knowledge and your point of view with us. And the floor is yours.
Hey, good morning. Um, it's a pleasure to be here today. And I am going to talk about a project that we have been doing the last 3.5 years with other colleagues and some lessons learned. And I hope that uh, this presentation will start some discussions and we will learn together. Um, First, I will talk about some lessons learned for this. They are important for this project that I learned in my life about artificial intelligence and some lessons learned from NASA. I will talk a little bit about complex systems from a systems engineering viewpoint. Uh, I will talk briefly, just 1 minute, about agile logistics. And also, I will talk about a project that we have, a very unique project. I think it's the only one in the world that we have been working the 3.5 years about um, using space exploration technologies to implement humanitarian logistics. I think it's the only one in the world, and it's well funded by the U.S. government. Um, right now, we are in a very intensive times that there are all the projects that we have funded by the U.S. government are heavily uh, investigated, but this one have been going forward for the next 2 years already have been approved to go even forward because of the interest of the government. Uh, we know that there have been 3 generations of this is one lesson learned about neural networks. They started basically in 1958, according to me. And then in 1986, Romelhart and McClelland got that famous book PDP. And in 1986, I was able to write, 1987, I wrote my first backpropagation neural network. I learned neural networks in 1986. And I had the opportunity in the year 1990 to listen to Romelhart, to listen to Geoffrey Hinton, and we worked with Geoffrey Hinton in 2010 in the third generation with his lab when he was in Toronto. We learned a lot about neural networks starting in 1986. One of the first big projects that I learned from neural networks was related to the TWA. This flight was going from New York to Paris, and in the middle, exactly going out of New York, exploded. This was a 747, and the problem was there were some tubes that you use in each of the tanks in order to measure the weight of the fuel. And then they were intrusive. And because of one of the sparks in one of the tanks, this airplane was destroyed completely. And with a company, we started a project to develop new products in order to get rid of those intrusive tubes. And rather than intrusive capacitance tubes, we created and we have some patents in order to have ultrasonic. And from that year, ultrasonic have been the standard for to measure fuel in airplanes, in Airbus and Boeing, for example. Therefore, we work with the companies We work with NASA, and from that was a set of products that now they are being used in the aviation community. And that was one of the first patents. This was in the year 2000 with neural networks to measure fuel, and they replaced it. And I learned from this in 1997 that, hey, yes, we can use neural networks in order to do regression type of problems. We can do neural networks to do pattern recognition type of problems. And it was very nice. But then from the same project, I learned that I can use AI in order not to do regression, not to do pattern recognition, but also to do optimization. Because there was another problem, where to put the sensors. And that is an optimization problem. And I learned, also I have another US patent, and it was a record when it was approved in just 6 months about using meta heuristics. And from the same project, I learned another lesson and another patent that we can also use these technologies in combination with others. But these conclusions are logical, but but to do it with real projects that other people are using your products is a different story. Believe me, it's a different story, and from the 1990s, basically. Therefore, those are the 3 lessons that I learned from AI that I will use then in the future project. Then in NASA, I learned several lessons. One of them, we have algorithms, divide to conquer, but there is a more difficult one, integrate to conquer. And in NASA, we started a project because things like devices like the NASA shuttle, there are many type of models. There are AIs developing cost models, operation models. There are electrical engineers developing other type of models. There are physicists, there are mathematicians. And we worked in 2003 to 2008 in a way to integrate all of these different type of models in different fashions. The way that they were able to be coordinated in time, in space, and in logic. And that was hard. We pushed the technology to the limits. We went to many places to learn, and finally we were able to conquer. Integration. Divide and conquer is not hard. Integrate and conquer is very hard. Therefore, I learned that from NASA, but I went to another project. I work in maybe one of the first tools ever done in order to predict the workforce requirements and the future activities in order to launch a rocket. Interesting thing, NASA has some information hourly from 46 missions. And basically, this was applied to the Phoenix Mars lander in 2007. And these tools developed, we are just talking about here, this is the Phoenix mission timeline that was going to look for water in Mars, actually. This is the design that started in 2003, the build and test starting in June, and then the launch preparation. I am just talking about these 3 months, from April 2007 to August 2007. And the tools built were able to predict how many workers you need, what kind of expertise you need for those 3 months, and also the building of the Gantt charts ahead, totally automated. based on the features of the mission, the type of rocket, and this was very valuable because it saved time from the project managers. It gave already. However, because of 2005, we reviewed this and we were able to think beyond, but it was so hard with the technologies available at that time. But we learned that there are some capabilities using historical data, the way that we can develop mission planning, operations planning from historical data in a very high level way. Therefore, those are some of the more important things. Now let's go back to emergency management. For this project, we start studying about the logistics, humanitarian logistics architectures available, and we approach it from a systems engineering viewpoint. We know it's a complex systems and it requires some ways to understand. The first thing that we did, okay, how's the environment right now? What is the functions that they have? And we developed a set of case studies, many case studies of successful operations in humanitarian logistics. And it was not me alone, there were other people working on this in the group. And we used systems architecting, basically. How should be the architecture of an organization that deals with humanitarian logistics? And we use the NASA way. The same way that they're developing the architecture to go to the moon, to go to Mars, basically you start with use cases. And from that, you will learn about the functions that the system should have. And then also together with the objective and goals, the characteristics and needs, and from that, the architecture of the system will come. Therefore, also we study what are the stakeholders of these organizations. And because we are scientists, we wanted to know in a systematic way, not just doing surveys, but what are the stakeholders? And what we did, we used tools to map the social media of some of these humanitarian logistics organizations, like Protección Civil in Chiapas, the Defensa Civil from Chile, and analyzing the mapping of these networks, we got the stakeholders at the local level, at the regional level, national level, continental level, and global level. And then, as I said, we got many case studies, in particularly successful ones, of the many disasters that they were handled with a good performance. And there were more than this. And based on that, we developed an architecture for humanitarian logistics organization. It needed to have a command and control area. It needed to have a public engagement segment or subsystem or system, as you wanted to know. It needed resource management. It needed a section of information and intelligence. And it needed a system about operational response and also connections to the infrastructure management. And that was the type of architecture that we consider ideal for one of these organizations. And then how to apply, what is Agile logistics? This is an approach that seeks to be highly flexible and responsive to change in demand and supply. Basically, we want to go quickly to any situation. And we are based in the grant that we got, we said, okay, how is to disasters? Basically, you have to respond quickly and efficiently to the logistics needs arising from that disaster. And we study different disasters, the one in Morocco, for example, the one in Turkey. Turkey has a very good air force and a good system. However, they were able to reach the area of disasters in more than 3 weeks. And usually the deaths are in the first days. And they say, okay, we are in the right track. And we wrote then a proposal to the US Space Force. There were more than 70 universities applying to this initiative. And we were the first university, the only university receiving funds to study agile logistics, emergency management using commercial rockets. Therefore, we were 3 professors, one an astronautic professor, another in aerospace, and myself in industrial engineering. And the goal of this project is to determine the viability of using commercial rockets to transport disaster relief cargo quickly and efficiently across the globe. And again, it was the first grant given by the US government from the Space Force to a university. And that was in 2021. And we start looking into the rockets. This is basically here. That one that we are concentrating is in the Starship, because it can carry more than 100 tons of humanitarian aid. Therefore, we have to interface with SpaceX in certain ways. Also, we are considering New Glenn from Jeff Bezos that can carry maybe 55 tons. And already we have many projects with Blue Origin. We know how their systems are assembled. And there are other types of rockets that we have been studying and interfacing with the companies. And of course, we have access to Kennedy Space Center, and we have access to the military part of the Cape Canaveral. And then there is another one, the Balkans, and all of that we have studied. And to give you a more information about the project is that this is Florida in 2024. This is not the NASA part. This is the Cape Canaveral part, and this is the launch pads of all the different companies that you can see here. It's an explosion right now. Therefore, if there is a disaster, you have to be ready to launch a rocket. Our goal is there is a disaster, and in less than 6 hours, it will be landing a rocket with more than 50 tons of humanitarian aid. And we can launch another one in the next hours or in the next day. Therefore, there are many companies building already here. There are billions of investments. Right now, I think we have more than $7 billion. This is booming right now. Therefore, in the future, in 2028, we will have one launch per day, one rocket per day. Therefore, there is always going to be available one rocket every day. Given a disaster, we can already use that rocket to send immediately, and in less than 6 hours, it will be landing with the humanitarian aid. Therefore, here, the last year, in 2024, we have more than almost 95 launches. This year, my God, this was in February, we have already more than 35, 40 launches. And in 2028, we are going to have one launch per day here at Cape Canaveral. It's amazing what is happening in Florida right now, and the SpaceX is having more than $5 billion investments. There is going to be in the next 5 years more than 30 to 40 billion dollars in investments here. This is more about Florida in 2025. As you know, Artemis is NASA is already building things here. These are things already built in NASA. For Artemis 2 and Artemis 3 that in 2027 is going to go to the moon, and Artemis 4 in 2028, Artemis 5 in 2029, and that means there is a lot of activity. From Lockheed Martin and Boeing, there is a lot of activity too, new rockets, and of course, SpaceX. This is a new launch pad being built. SpaceX has invested billions of dollars, thousands of millions of dollars. This is the one here is the Blue Origin facility of more than $1 billion to assemble rockets. 35 miles from here, from where I am. And this is their new launch pad that is already another $1 billion facility, and it's going to be, they are going to have, Amazon is going to have a great network of satellites, and SpaceX is launching more than 12,000 satellites. I think already they surpassed maybe several thousand of satellites. And there are new companies coming, Firefly already, and this is from my house. Walking at night, you can see a rocket. Yesterday, I saw a launch of a rocket. I mean, every 3 days I see a launch. Therefore, the activity is great. Oh, this is the real sound. And let me see here. Maybe I can see that. This sometimes 36 hours after one of the SpaceX is launched, you can see the satellites. This is a last mile delivery problem. Right now, the rockets from SpaceX, they can launch 20, 30 satellites, and then you have to put them in different orbits. Therefore, it's a last mile delivery problem. And at night, sometimes people thought at the beginning that was, you can see them also at night. Therefore, there is a lot of activity in that area here in Florida. Everything is booming from that. Therefore, let's go back a little bit to the project. Therefore, in 3 to 6 hours, we have to put everything in the rocket. 50 to 100 tons of humanitarian aid. Then in 60 minutes, we'll be landing that aid or the entire rocket in the right place. And then the authorities will pick up the 50 tons or 100 tons. Therefore, in just less than 6 hours, there will be everything there. There is a video here of 2021 that shows the concepts of this. Basically, this is a conceptual video. You can get it in YouTube, actually. And these are, there is the rocket. And everything opens. The cargo can go in automatically. There is a disaster, a hurricane detected. And then in less than 6 hours, the rocket can be launched. And to make this feasible financially, anyway, this will be free to any nation. The rockets, they have to be reusable. The way that the cost will go down. Basically, right now, our preliminary information of cost is around $20 the kilo, basically. And then the rocket will go and land in the disaster area. There are still details that we don't know. It's research, basically. And then everything can go out. And automatically, everything will be robotized. Therefore, people can pick the things out of the rocket. Let me talk briefly about the project. How many students we have used? We have used more than 260 undergraduate students from industrial engineering, from data science, that they are experts in artificial intelligence, from aerospace and mechanical engineering. This is amazing. And the students, they work in this project, they put in the CV, and usually they get great jobs here with companies such as Blue Origin, Boeing, Lockheed Martin. We have had more than 12 master students, more than 4 PhD students from industrial engineering, data science, and aerospace engineering. We have had 1 or 2 postdocs and 1 senior personnel, and many of them have been able to do internships in government labs and in companies. And there are some things that, one of them is the manifest, what should be inside of the rocket. In that, we talked to Mexico to see what they would like to see, especially if there are volcanic eruptions, earthquakes. We went to Chile. We talked to the FEMA of Chile, with also the Army of Chile, and we talked to the Red Cross of Bangladesh, and with medical doctors, and basically what should be those 100 tons, what should be there inside of the rocket in general, what they would like to see. And we also we developed new concepts and architecture for what is a spaceport, what is a space operation center. This is unique. Nobody has done that in the past. We have built different mechanisms for operations, algorithms, robotics, automation. We have used many techniques like operation research, transfer learning, similar to whatever they do in ChatGPT, but in this case, we do for trajectory of rockets. This is the first group that does that. Study large language models. And we have developed more than 30 simulation models. And we are able to put several simulation models together using meta heuristics, as you know very well. And again, artificial intelligence is one of the major things that we use in this project that is already continued. We don't have we have already good plans. And whatever we are showing you is 1 year behind because we always try to get permission. As you saw, there is a permission here approved for public release to be sure whatever we are doing. And yes, we are using large language models to try to do mission planning. If there are natural disasters, then we can use reinforcement learning. Basically, yes, some conclusions. Emergency management organizations are complex systems. You need subsystems like resource management, command and control, public participation to operate efficiently. There are many nonlinear interdependencies. Um, we are the pioneers right now in using commercial rockets. We have the right environment. We have some of my students, they work for Blue Origin. Right now, the director of Kennedy Space Center was my student. The sub-director of Kennedy Space Center was my student. One of the vice presidents of SpaceX was our student. That means our students are all over. The University of Central Florida has graduated more than 1,400 NASA engineers. And we are the #1 university giving students to defense and aerospace areas. Optimize warehouse configurations and the use of autonomous machines enhance logistic processes. Um, and therefore, we are using AI technologies in general, such as large language models, reinforcement learning, all the things that you use, we use it. And we learn from the papers that people publish in POMs. We learn from it's not like we build everything from scratch. We learn from organizations like POMs. We learn from Informs. We learn from technical reports from other universities, from other people. As you saw, we go to Chiapas, Mexico, in the border with Guatemala to learn from them about what are their needs. We go to Chile. Those two places, Mexico and Chile, we consider them to be some of the leading organizations in humanitarian logistics in Latin America. Therefore, we learn from everybody and we apply it and try to adapt it to our needs. Therefore, this was very brief, and I have some papers if you want to learn more. Again, everything is like 1.5 years behind, but if you want to learn more about the project, I can send you several papers about it. Okay, with that, I conclude my presentation. It was very quick, but hopefully it gives you some ideas of whatever we are doing. And whatever Florida is doing right now, Central Florida is doing right now, everything is moving here. Companies are moving in. Students are building new companies, new type of rockets, and, and, and the Hispanic community is very heavy involved in that. Thank you.
Great. Thank you, Dr. Rabelo, for your great presentation. It's very exciting to see what you're doing there. And so we are gonna open the floor for questions. I see that Felipe has some questions for you, but he told me he cannot open his microphone, so I'm gonna ask it for him. The first one is, how exactly works the meta heuristics and the integration of AI optimization?
Okay, in this problem we have in this problem we have 1,000 problems, and then for example, you can use optimization, traditional mixed integer linear programming, to select the place where to put the launch pad. That is just one problem, where I am going to put the launch pad to launch the rocket. Remember, Starship is massive. And we have to take into consideration what the aerospace engineers, they tell us. There are 3 effects of a launch. Of launching a rocket, there are 3 effects. One, if it explodes, it's 3 effects. One is the debris. The other one is the blast. The sound wave is massive of an explosion. It's like a nuclear bomb. And the other one is some part of the fuel, where that goes in the explosion. And then we have to take in consideration what the aerospace engineers, they think. And based on those mathematical models, we add into the mixed integer linear programming models to decide where is the key point to put those launch pads. And then that's one question. Then there is another optimization problem. How many launch pads I can have? Wow. Now there is other optimization problems is I have a network of warehouses. Where I should put the warehouses? Remember, in that area is hurricane area. Oof. And that area is just 6 feet above the sea level. Where? That means that I can tell you, I just tell you 4 or 5 optimization problems. And we can go on and on and on and found. Then let me tell you another thing.
Great.
Have you seen the Starship when this experimental flight? How many gallons of water they throw to Starship? Around 250,000 gallons of, it's not fresh water to consumption, it's a
course.
kind of dirty water, but it's water. And then that's important in order to mitigate the sound blast. And then where are going to be the new water plants? That's another optimization problem. Where we are going to put, one interesting thing is that New Glenn from Jeff Bezos, the new rockets, except the ones from NASA, they use liquid methane. Where are those plants are going to put? What the pipelines, another optimization problem. Etc. etc.
I know
Therefore,
some.
not one single optimization
I can
problem. There are
imagine.
many. For that reason, we have 260 undergrad students because it's and anyway, and there are also questions I cannot answer right now because we are investigating right now.
I can imagine. Thank you. So I have a personal question for me as a teacher, as a professor here in Bolivia, in industrial engineering. It's interesting to see when someone from the area goes and work in such beautiful projects with a different perspective of what we think that we should do as industrial engineers. So I want to know from your perspective, what do you think is the approach, or what do you think is the benefits of having industrial engineers? What is our contribution to this type of projects? And how would you motivate students in this area to go to research and to maybe not be only focused on the industry itself?
Okay, at the beginning, you read at the beginning, if you everybody says the word rockets, and then everybody thinks about aerospace, mechanical, electrical, but actually industrial engineers are the most important part. Logistics, quality is basically, Kennedy Space Center has a division of only industrial engineers. And what they do is logistics, quality, they do discrete event simulation, they do ergonomics, human factors, human engineering, cognitive modeling. Especially when there is an emergency situation, you know, the astronauts, the height of an astronaut cannot is between 5 feet 4 inches to 6 feet 2 inches. Because of the centroid of gravity, all of that are industrial. Therefore, they are so important here. So important here. Therefore, there are in IEs areas all over, operation management areas. And as I told you, usually they are the ones that they get the leadership positions. The aerospace, they work for them. Don't tell them that, but the aerospace, they work for the industrial engineers. At the end, the IEs and the operation managers are the ones that they have the VPs, the vice president, the directors.
That's very motivating. Thank you.
Well, Dr. Rabelo, we have here another question in our chat. This question is, I really like this one. In what ways Latin American countries position themselves as leaders, or how can they do it, in innovative disaster response logistics on a global scale? What is that role that Latin American countries can do, role as a nations and as professionals in the region?
These organizations that they do, I won't talk about countries, but let's say one country in Central America that I know very well. They have something for disasters. They just copy everything from everywhere. In Chile, it's different. They have the disasters, however, they have grants. They study, they do research about the landslides, the mechanics, the soil mechanics of the landslides are being researched in Chile. That is a contribution to worldwide level of disaster management. Now you go to Chiapas, Mexico, southern, maybe one of the poorest states of Mexico. However, they have a university just for disaster management. And you can see and also they do the research, specifically when they have indigenous population, how to deal with that. People that they don't speak Spanish. They have like 25 different type of languages. We still in our project, we are learning from them. We will have to learn from them. How about this rocket landing in the middle of Africa and they don't speak any English? How to deal with that? This is an Chiapas already is ahead of that. Therefore, Latin America is really, some places are giving real, but you have to have that drive to do more than just to be prepared, maybe just to be prepared. They have to investigate and publish and interact in a different way beyond just copying others. And these are two examples that, yes, you can do it.
Great, thank you, Robalo. Agata, you have another one over there?
Yes, I have a last one in the chat. It's also from Felipe. What he says is that I understand your approach is related to cargo aid, but which would be your thoughts related to healthcare personnel and operations?
Okay, this is an outstanding question, and this is something that we want to learn more. In this case, remember, we are just going from United States perspective. United States will not charge the country that is in need. Let's assume that it's Colombia. There is some flood of the Magdalena River, and the president will call the president of here, and they will, hey, let's send the one rocket at least with 100 tons. We just pack it whatever they need. Over there, we will have in the future to train those guys that they are going to receive the cargo. Therefore, yes, that is something huge in the next 2 to 3 years that we will have to deal with. How to train those guys from the healthcare to manage the cargo that is going to be. And that is something that I cannot give you an answer right now. We are doing simulation, but it's also a human thing. And yes, a good question. I don't have a good answer right now. It's something that we are going to be dealing in the next 2 years. We are learning from other places. I think there is a university that wants to cooperate with us in that area. It's not a United States university, and we would like to learn from them in that area. The post-disaster problem. We don't have, I don't have it right now. We have not reached that area of that is important for this research. But again, for that reason, we have there is other people that they know more than us in that area, and we will learn from them. And there is a university that is outside the United States that they, based on one of these talks that I give, sometimes they say, hey, we know more than you about that. I say, yeah, we want to learn from you. And they are just willing to cooperate with us. And
That's
I will
great.
give you a better answer, again, based on the lessons learned from that university.
And they're gonna have you here to talk about it. So
Yes.
thank you so much for your response, Edgar. I just gonna give you the floor to close the session.
Sure. All right. Wonderful session. Thank you very much, Professor Rabelo. We enjoyed very much your talk. Thank you for all participants that made those great questions. Remember, we have more questions, but we don't have more time. So you can reach us. You can reach Dr. Rabelo through their networks. And remember, we will have more of those webinars in the future. So make sure to be attentive to what we'll do. And with that, thank you, Dr. Rabelo, for this amazing session. We enjoy very much.
Okay, see you. Thank you. A pleasure. Un placer haber conversado con ustedes.
Igualmente, gracias.
Muchas gracias.
Gracias, Dr. Rabelo. Obrigado, everyone. Gracias.
Muito obrigado.
Bye-bye.
Bye.